Hi, it's Mr. T here. Welcome to this video on law of reflection. So what we're going to look here is what happens to a light ray when it hits a mirror. The first type of mirror we're going to look at is a flat mirror. Now, remembering that a light ray travels at 300,000 kilometers per second, and it travels on a straight line, and we represent it by a line with an arrowhead on the end to show the direction. So the light ray that is going in towards a mirror is called an incident ray. Where the incident ray hits the mirror, just here, we can draw an imaginary line that's 90 degrees or perpendicular to the surface of the mirror. This line we label the normal. We can also draw an angle. So we have this angle between the incident ray and the normal. This angle is called the angle of incidence because it's the angle between the incident ray and the normal. Right, let's go and draw what happens to this light when once it hits the boundary. It reflects off and it produces this ray called the reflected ray. And then again we can draw another angle, and this angle is called the angle of reflection. Now this leads to the first and maybe one of the most important laws to do with light and to do with mirrors, and this is the law of reflection. The law of reflection states that at whatever angle of incidence the light ray comes in at, it will leave at the same angle of reflection. So the angle of the incident ray to the normal is equal to the angle of the reflected ray to the normal. Okay, well let's apply this to a situation. Here is a flat mirror with an object that is a distance away from the flat mirror. DO is the distance the object is away from the flat mirror. So one thing to note is that when light rays leave the top of this object, they will diverge. They all move in different directions. So someone who is over on the right can see this object and someone on the left can see this object. So we'll draw one of the light rays coming off. It goes towards the mirror and it's going to reflect, obeying the law of reflection. So I'll draw it here. Now imagine that someone was looking at this light ray. Where would that person think that the light ray had originated from? They would have thought that the light ray has traveled in a straight line because that's a property of light, it travels in straight lines. So we can draw what we call a backtrack, or a line that goes behind the mirror. Is not really where the light ray goes, but it's where a person would think it went, an illusion. Well, let's draw another light ray coming off the top of this object. This blue one here, and it's also going to obey the law of reflection. So its angle is going to be slightly different because it has a slightly different angle that it hit the mirror at. So now we have another light ray that the person is looking down, and when they look down the length of this light ray, they will follow it, and they will follow it to this point here where the two light rays meet. Now the top of where these two light rays meet is the same point as, so the eye would think that this is where they originated from, or the top of the object. But this is not the actual object, this is an image. This is the reflection we see of the object. Now because this image is on the other side of the mirror, it is called a virtual image. We say that it is upright because it's standing the same, it's standing upwards, and we say it's the same size as the object. The distance between the mirror and this image is called DI. For a flat mirror, the distance of the image is always equal to the distance of the object. And for a flat mirror, the height of the object is always equal to the height of an image. Let's have a look very quickly at a couple of different mirrors, and these are called curved mirrors. So this first curved mirror here we're going to look at is called a concave curved mirror. Now We can remember that this is a concave because the inside of this mirror that the light is going to reflect against is a cave shape. Now we are going to draw three different rays hitting this mirror. An incident ray that is parallel to the axis, and that's supposed to reflect through something called the focus. An incident ray through the focus. Well, let's have a look. I'll draw some of these. So the first one I'm going to draw is an incident ray going parallel to the principal axis. This is this line through the middle of this curved mirror. Now it will bounce back through, well, let's draw the normal here. This is the normal of where this hits. Notice this dotted normal line is perpendicular to the surface of the mirror or perpendicular to the tangent. So when we draw off the reflected light ray from this incoming ray, we see that the angle between the normal are equal. So let's draw the next light ray. The next light ray we're going to draw is the one that goes through the point called the focus and then bounces off parallel. So this light ray will go through this point here in the middle and bounce parallel. And it does the same thing as the one that went parallel and then bounced through the point. They follow those rules. The third light ray that we could draw on this diagram is one that goes directly along the principal axis and bounces back again. Now the point where the light rays meet is called the focus or the focal point. I could draw any parallel light ray bouncing off the mirror and it would always bounce through the focus. The point where the normals we drew from the inside of the curve, the point where they meet is called the center of curvature. It's the center of the circle that we would transcribe from this curve. So these are how the light rays behave when they reach a concave mirror. This is called a converging mirror because the light rays are coming towards each other. They are converging. So here's a different type of mirror. This one here is called a convex mirror or a diverging mirror. Notice now the curved side, it's curved outwards to the direction of the light rays. So here's one, number 3, the first light ray I'm going to draw is one that goes along the principal axis and it will bounce directly back. Now the reason it bounces directly back is because its angle to the normal is 0 degrees, so it bounces off at 0 degrees. The second light ray that I draw comes in parallel and it will reflect off, remember, at the same angle towards the normal as the angle of incidence. So there's an angle of incidence, here's our normal, the angle of reflection is going to be exactly the same. Remember what we did before about the flat mirror though, is that as this bounces off and it's diverging, when someone looks at this light ray, they're going to think that it appeared along this line. Well, let's do one on the other side. So the light ray hits the mirror, it bounces off the mirror, but where did we think it come from? Right here, and this point where we think it originated from is the focal point. Now notice for this type of mirror, a diverging mirror, the focal point is on the other side. And then, of course, we still have the center of curvature as well. Now one point about the center of curvature and the focal point is the center of curvature is always twice the distance as the focus or the focal point. Okay, thank you. I hope this video has helped.